Hi there, welcome to the Unit 5 review packet for Algebra 1. We're dealing with quadratic functions. So we've got that x squared part to our equations in these problems. So we're just going to start, we're going to go through it all. If you're one of my students and you just copy things down in here, shame on you, because not only are you not getting the practice you need to be successful on the test, that's really what matters, but you're doing something you shouldn't be. Anyway, so the big thing though, you got to get the practice. You got to know how to do this yourself. Whoop-de-doo if you can copy this down and get a 10-point homework assignment, but you can't do the test. So you need to know how to do these things for the test. So let's get started here. Factoring something like this, we've done things like this. We're putting that last number on the top, bottom number on, or the middle number on the bottom. We're thinking of the factors of that last number. So factors of 40, you've got 1 and 40, 2 and 20, 3 doesn't work, 4 and 10 though would work, and 5 and 8. The right combination, the only way to get 18 from those would be to do that if you're doing basically 20 minus 2. So one of these is going to be a -2 as a factor, the other one a 20. If we factor it out, we're using these values. You've got x minus 2 times x plus 20. And it just says to factor. So that's all we're doing here, just factoring it out. Number 2, didn't talk about a GCF here with number 1. There was no GCF, or greatest common factor, except for 1. And that's also the case here. So we can go right to this idea. We're looking for 64 as the product, 16 as the sum. If you write out the factors of the last number, the factors of 64 would be 1 and 64, 2 and 32, 3 doesn't work, 4 and 16, 5, 6, 7, none of those work. 8 works though, 8 and 8, and that's it. So that's the right combination right there. No more factors, no more pairs of factors of 64, but that's the right combination. Everything's positive, so these would have to be positive as well. The factors would be x plus 8 times x plus 8. You could also say x plus 8 squared, and that would be a correct answer as well. For number 3, factoring this one, we want to get a GCF out here first, and it's easier to deal with x squared than negative x squared, so I'm going to factor out a -2. If I factor out a -2 out of everything, really I'm dividing everything by -2. I'm thinking about doing that, and then I'll put what I have after I do that in the parentheses here. So -2 x squared, this divided by that would be -2x, and then this divided by that would be -80. From there you can factor this part farther. So this is going to equal -2, and then you can break this apart. You've got an x and an x. We're thinking of things that multiply to -80 and add to -2. If you write out the factors, that looks like this: 1 and 80, 2 and 40, 3 doesn't work, 4 and 20, 5 would work, 5 and 16, 6 no, 7 no, 8 yes, 8 and 10, 9 doesn't work. But that's your right combination right there. It's got to be 8 and -10 to make this happen as a product and a sum. We use those as our factor values. It's x plus 8, x minus 10. With all of these, if you multiply them back out, if you redistribute the x and redistribute the 8, same thing here, idea here and here, you get what you started with. That's how you can check your answers with these. Let's look at number 4 and 5. We're going to try to find f of x given this equation and then given this one. So this looks like a normal one. We're just going from the vertex over 1, down 1, over 2, down 2 squared, which is 4, and so on. So it is opening down on this one. F of x then has to have a negative sign out in front, and then we just use the solutions right here, which would be -7 and -3. And the factors are opposite of those solutions. So it's x plus 7, x plus 3 would be the factors. Multiplying this out, you get x squared, and then x times 3x, or x times 3 is 3x. 7 times x is 7x. 7 times 3 is 21. If you combine like terms, you'd have 10x right there. The negative sign would make everything change signs, make everything negative in this case. This would be the equation for that parabola. So f of x equals that. Then finding f of 5, you're just plugging in 5 in 4x. You've got negative and 5 squared. Not squaring the negative here. It's negative and then whatever x is squared. Minus 10 times 5 minus 21. That's going to give you negative 25 minus 50 minus 21. That combined together is negative 96. For number 5, same sort of thing. This one opens up, but it is a normal. It's not wider or narrower. It's 1 and 1, 2 and 4. And so we just look at our solutions. 2 and 4 are our solutions. So our factors are going to be x minus 2, the opposite, and x minus 4, the opposite there. And then distributing both terms, looks like x squared plus, or minus, minus 4x minus 2x plus 8. That's going to be x squared minus 6x plus 8 on that one. So that is your g of x, and g of negative 3 looks like that would be negative 3 squared minus 6 times negative 3 plus 8. So this would be 9 plus 18 plus 8 would be g of negative 3. That's going to equal, if I add all that together, this would be 27 plus 8, 35 right there. Moving on to number 6, factoring again. So look for GCFs first. This one has a GCF of 13 for the number and x. You can take an x out of both. So this would be 13x, and then think of dividing each piece by 13x to get the part in parentheses. So we would have right here 13x times x. That would give you 13x squared. Divide this, we'd have a minus 3. There's no more factoring that can be done on that one. You're done right there. On this one, factoring what you see there, divide by 5, divide by 5, divide by 5, because we can take a 5 out of everything. We're going to have 5 times x squared plus 14x minus 51 right there. From there, you can factor that out, negative 51, and we're looking for 14 as the sum. If you write out the factors of that last number, 51, talking about 1 and 51, and 3 and 17 is the only other combination. That's the one that's going to work as long as the 3 is negative and the 17 is positive. So here we would have 5 times x minus 3 and x plus 17 right there. That would be it. Can't factor that anymore. On this one, no GCF to take out of this one, so here we can just do our x right away. We're looking for a negative 20 as the product. This is like an invisible 1 there, so 1 as the sum. If you write out the factors of 20, you got 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. This has got to be the right combination. That's a difference of 1 right there. As long as the 4 is negative, that's going to work. So you'd have x minus 4 times x plus 5. Moving along to number 9, find the solutions now by factoring. We want to get one side equal to 0 when it says to find the solutions by factoring. That's our first step. So to do that, I could add 2b to both sides here. That's b squared plus 3b equals 0. From there, now you're factoring. GCF, you take out a b out of both of those terms, divide each term by b, and you're left with b plus 3 inside the parentheses. So from there, again, you can factor out the b. I'm really thinking of dividing by b. So that's here. You could say b equals 0 and b plus 3 equals 0. You could set those up as equations and solve, but what makes this factor 0? It's 0. What makes this factor 0 right here? It's negative 3. Over here, if you add 9r squared to both sides, you're going to get one side equal to 0 like we want. That would leave you with r squared plus 20r plus 36 equals 0. Then from there, now we can do this. We've got our 36, and you're going to have 20 on this one. You're writing out the factors of 36 if you find that helpful. It would be what you see here. And the right combination has got to be that one. So 2 and 18, we're saying r plus 2 times r plus 18 equals 0. And again, you could write this out if you wanted to. I'll write this out in red on this one. So you could say r plus 2 equals 0. You could solve that for r. You can say r plus 18 equals 0. You can solve that for r. Subtract 2 from both sides here. R equals 2. That's one solution. Subtract 18 from both sides here. That's r equals negative 18. That's your other solution here. Oh, this was supposed to be negative 2 right there. Sorry about that. So you've got two solutions here. So you can do it like that, or you can just look at it and say, well, negative 2 plus 2 is 0. So that's one solution. You can look at it here and say negative 18 plus 18 is 0. That's another solution. Both of those values would make the whole equation true, would make the whole equation equal to 0. Number 11, finding vertex form. It's actually a second number 10. That was a little typo there, but this one we're looking at vertex form by completing the square. So always think about putting those first two terms in a group, or putting them together as you're completing the square. Here we have x squared plus 24x, and then divide this term by 2 and square it. Divide the coefficient by 2, that's 12. Square it, you'd have plus 144. The number here has to be the opposite of the number here, so you're going to have a minus 144 there. We have to keep this equation here equivalent to what we started with. So I can't just randomly add 144 to the equation. I have to do the opposite to keep it balanced out, to keep it equivalent to what we started with. So this would be x plus, and then it's always half of that number goes right here. If you were to square this back out, do your distribution x plus 12 times x plus 12, you get what you started with. So this, and then we'd have plus 3 after that. This is vertex form. So we can stop right there. The vertex itself would be the opposite here of what you see in parentheses, negative 12 for the x value, and the same outside, positive 3 for the y value. As we move on here, number 11, you want x squared and not a negative x squared. When you're going to complete the square, you just want a plain old x squared out in front. So we're going to have this is equal to, take out the negative. If you take out a negative out of this term, you also have to take out of this term. So you're going to have minus 4x, and then you got two blank spots, plus 9. So in this blank spot, divide this by 2 and square it, you have a plus 4. And then this is really a negative 4 right here. This is a negative 4 in disguise. That's because there's this negative right here. So if you distribute that back through, that's actually a negative 4. That looks like a 9 there. Let me just make that clear. So that's a negative 4 in disguise right here. You have to put the opposite of what that is right here. So a positive 4 has to go right there. This leaves you with negative on the outside. X, divide this by 2. That's minus 2 squared plus 13. That's vertex form. That's it for that one. Now to complete the square and graph the parabola. So same idea. We're going to complete the square. So take out the negative. You want x squared as your first term there. If you take out a negative out of that, you've got a plus 4x, blank space, minus 1. So right here, you're going to divide by 2 and square. It's going to be 4 there. And this is a negative 4 in disguise because of that negative here. So this is a negative 4 in disguise. We do the opposite there, a positive 4. This would be x plus 2 squared then in the parentheses, plus 3 outside the parentheses. This is completing the square. So that's part of what we're looking for. The vertex from there would be negative 2, the opposite here, and then positive 3. So negative 2, 3. It opens down because of the negative sign, and there's no number after that, so it's just a normal parabola where you go 1, 1, and 2 and 4. You could make an XY table, but if it's just a normal parabola, 1 or negative 1 out in front, it's always 1 and 1 squared, 2 and 2 squared. You could go more, 3 and 3 squared. You'd go 9 down, and so on. But I'm good. If you're my student, I'm good if you just draw that part at least. I'll do this one in green over here. So on this one, I'm going to complete the square using those two terms. I'm going to factor out a 2. So that's minus 4x. And then here you'd have a plus 4 in that spot. And this is actually a negative or a positive 8 in disguise because of that 2. So 2 times 4 would be 8. So the opposite of that is negative 8. That goes there, plus 5. That's x minus 2 squared minus 3. So there is the completed square. And your vertex there would be 2, opposite what you see there, negative 3. So 2, negative 3. And this one, because of this 2 right here, it's going to grow twice as fast. So you normally would go 1 and 1. It does go up since it's positive, but now we're going twice as fast. So 1 and 2. Normally 2 and 4, now twice as fast, 2 and 8. So 8's going to be up to there, 8 over. Symmetry on the other side, so it looks exactly the same on the other side. And then draw that with the nicest parabola you can. That is not the nicest parabola I can, but it's a little hard sometimes to draw as well as I want to with this device here. So that's the idea. Number 14, find solutions now by completing the square. So we're still completing the square. We're still putting those two parts together. We're saying x squared plus 6x, blank spot, another blank spot, minus 91 equals 0. The blank spot would be this divided by 2 squared, so 9. And that's nothing in disguise, it's just a straight up 9, so opposite is negative 9. This would be x plus 3 squared minus 100 equals 0. You can add 100 to both sides from there. You've got x plus 3 squared equals 100. From there, take the square root of both sides. So you've got plus or minus the value right there. The square root and square here will cancel. X plus 3 would be plus or minus the square root of 100 is 10. Subtract 3 then. You've got x equals negative 3 plus or minus 10. And that would be negative 3 plus 10 is 7. Negative 3 minus 10 is negative 13. So two possibilities there are those two values. For 15, same thing. Complete the square, group those together. This would be x squared plus 22x divided by 2 would be 11 squared. 11 squared would be 121. So that's a minus 121. After that, minus 75 equals 0. This would be x plus 11 squared, then minus 196 equals 0. If you add 196 to both sides, and then take the square root from there, making sure to say that's plus or minus on that side there, that would cancel. X plus 11 would be positive plus or minus 14. So subtract 11 from both sides, there's your answer. X is negative 11 plus or minus 14, which means x could be negative 11 plus 14 is 3. Negative 11 minus 14 is negative 25. Number 19, nope, number 16, I skipped a couple of slides there. Factoring again, so back to that. No GCF here, so I'm just going straight to this. Negative 63, negative 2, factors of 63. That's going to be 1 and 63, 3 and 21, 5, 4, nope, 6, nope, 7, yes. So 7 and 2, there's, or 7 and 9, that's your right combination to get you negative 2. The 9 would have to be negative. This would be x plus 7, x minus 9. Excuse me. So from here, GCF, we can do that on this one. 6 is the GCF. So factor it out. Don't get rid of it, but just factor it out. And you've got that left after you divide everything by 6 here. And then from there, same thing as we have been doing. 1 on the top here and 2 on the bottom. So there's only one combination that'll get you 1. That's 1 and 1. It's got to be the right one. And everything's positive, so these are positive ones. So the 6 stays out there, x plus 1 times itself, x plus 1. You could say 6 times x plus 1 squared as well. Factoring this, if you know the shortcut for differences of squares, you can use that. Or you can think of this as x squared plus 0x minus 16. And that, you could go to this from that point. Factors of 16, you've got 1 and 16. You've got 2 and 8. You've got 4 and 4. The right combination has to be that. 1 has to be positive. 1 has to be negative. This would give you x plus 4 times x minus 4. And again, multiplying these factored things back out, redistributing things back through, gets you what you started with. That's a great way to check your answer. Finding solutions by factoring now. So I'm going to get one side equal to 0 like before. And let's write this in standard form. So I would have 1x squared, or just x squared. I'd have 14x, and I'd have minus 51 equals 0. The 7x's would cancel out there. We're looking for factors of 51. And this is your only combinations that would multiply to negative 51 here and add to 14. So it's got to be this one, and the 17 would have to be positive, the 3 would have to be negative to make that happen. This is going to be x minus 3 times x plus 17 equals 0. Right here, that would be 3 for one solution. This negative 17 would make that factor 0. So negative 17 is the other solution. Here we can add 3x squared to both sides and subtract 14x from both sides to get one side equal to 0. These would all cancel. X squared minus 15x plus 56 equals 0 there. The factors of 56 are going to be 1 and 56, 2 and 28, 3 does not work, 4 does work, it's 4 and 14, and we would have 5, no, 6, no, 7, yes, 7 with 8, and that's the right combination because we're looking for a positive 56 and a negative 15. You add them together, you get 15, so if they were both a negative, you would have a negative 15. That would work out just fine there. So x minus 7, x minus 8 equals 0. This one, 7 would make the whole thing 0, or 8 right here would make the whole thing 0. 21, finding vertex form by completing the square. So some more practice with those. Completing the square, we want to factor out whatever it takes to get a x squared by itself there. Factor out a negative and make that a positive 8x. Blank space, minus 13. The blank space here, divide by 2 squared. That'd be 16. This is a negative 16 in disguise because of that negative out here. So you're going to have a positive 16 here to cancel out that negative 16 that's here. So from there you got a minus or negative, and then x plus 4 squared, and then plus 3 after that. That's vertex form. That's it, you're done. On this one, same sort of thing. Group those together. Take out your negative. And here you're taking out a negative out of a positive, so that would be a minus 10x, blank space, minus 21. Divide this by 2 squared, that's 25. And again, this is a minus out here, so that's actually a negative 25 in disguise that you just added to the equation. The opposite of that goes right there, positive 25. So minus or negative x minus 5 squared plus 4. You have completed the square. From there, you are done with that one. Graphing the parabola, it looks like we could do this either with an xy table. You could find the vertex using that negative b over 2a idea and then making a table, or you could complete the square. I'm going to complete the square because I think if we know how to do that well, it's going to go a little faster. So again, you want to get x squared by itself here. You'd have to take out a negative 2 to make that happen. And if you take out a negative 2 out of that, divide that by negative 2, you'd have negative 2x. Blank space, plus 2. And that blank space would have to be a plus 1 if you divide that by 2 squared. And then this is actually a negative 2 in disguise because negative 2 times 1 is negative 2. So after that, you'd have to have a positive 2 in that blank spot. This would be x minus 1 squared plus 4. So this is vertex form. The parabola would have a vertex of the opposite of that is 1, and then the same there is 4. So 1 and 4. It opens down because it's negative, and it goes twice as fast as normal because that's the 2. So we have 1 and 2, and then 2 over and 8 down from there. Symmetry on the other side. So it looks like that, there, and there. Connect those with a nice looking parabola, and you're good to go. For number 24, it looks like we have to take out a negative 1/2 here. So this would be negative 1/2 to get a plain x squared right there. And we're grouping these together. So to to get a negative 1/2 taken out of that, it's like multiplying by the reciprocal. Multiplying by 2 is the same as dividing by the 1/2. So the negative comes out, this would be positive, and then that would have to be 8x. If I multiplied negative 1/2 back through to 8x, I'd get negative 4x. And then a blank space, minus 6. So here you have to have that divided by 2 squared. But this is actually a negative 8 in disguise that we just added to the equation. Negative 1/2 times 16 is negative 8. So you have to have a positive 8 here to cancel that out. This is going to be negative 1/2 times x plus 4 squared plus 2 on the outside. This is your vertex form. That means your vertex is negative 4, 2. So you go back 4, you go up 2. This one opens down because that's negative, and it goes half as fast as normal. So normally it's 1, 1, and now it's going to be 1, 1/2. Normally it's 2, 4. Now it's going to be 2, 2. And then symmetry on the other side. So that is number 24. Number 25 says to graph the parabola. Nice thing here though, it's already in what form? Vertex form. So this one, the vertex, is staring you in the face right there. It's negative 4 and 5. So we're going to take that, we graph that, negative 4 up 5, that's going to be that point right there. It opens down because it's negative, and it goes twice as fast because of that 2. So this would be 1 over, 2 down, 2 over, and 8 down. And that's going to be right, that's 1 too far. There we go. It's going to be right there, and then right there, and right here. Connect that with a parabola, and you're done on that one. 26, same thing as 25. It's already in vertex form. How handy, we can just say that the vertex is 2, the opposite there, negative 2, the same number there. So the vertex is that, 2, negative 2, that's right there. It opens up because this is positive, and it goes twice as fast because it's a 2 and not a 1. So normally 1 and 1, now it's 1 and 2. Normally 2 and 4, now it's 2 and 8. That's all the way up to the top there. And same thing, symmetry on the other side. And so there's your graph for that one. Number 27, find solutions now by completing the square. We did some of these already. Completing the square, right there you'd have x squared minus 2x divided by 2 squared is 1. You'd have a minus 1 outside there, and then a minus 3 that's there equals 0. This would be x minus 1 squared minus 4 equals 0. Add 4 to both sides. Take the square root of both sides from there. Don't forget your plus or minus there. Square root and square cancel. X minus 1 plus or minus 2. If you add 1 to both sides, that's x equals 1 plus or minus 2, leaving you with 1 plus 2 as an option 3, or 1 minus 2 as the other option, negative 1. On this one, group these two together. You've got x squared plus 4x divided by 2 squared there is plus 4. That's a positive 4, so that's a negative 4 after that. And then plus 3. This would be x plus 2 squared minus 1 equals 0. You can add 1 to both sides. You've got x plus 2 squared equals 1. You can take the square root of both sides. Don't forget your plus or minus there. And you've got x plus 2 is plus or minus 1. The square root of 1 is just 1. Subtracting 2 leaves you with x equals negative 2 plus or minus 1, leaving you with these two options. Negative 2 plus 1 is negative 1, or minus 1 would be negative 3. Number 29. This one, we should be graphing this one. We can use completing the square. We can make a table. It doesn't say, you can take your pick. I'm going to use completing the square. So this would be negative and x squared. If I take a negative out there, that's a minus 6x. And then I would have plus 9. This is a minus 9 in disguise because of that negative. So I have a minus 9 here. That means I have to put a plus 9 there. This would be negative, and then x minus 3 squared minus 1. So that's vertex form. That's very important. The vertex itself is the opposite of what you see there. So negative 3 is what you see. Positive 3 is going to be the vertex, the same as what you see there. So negative 1, 3, negative 1 is right there. It opens down because it's negative out in front, and it's normal pace. There's no 2 or 1/2 or anything else out there, so it's just the normal 1 and 1. It's opening down, so I go down 1 instead of up 1. Then it's normally 2 and 2 squared, which is 4. So right there and right here. That would be the graph of that parabola. And the vertex of this one, we already said, was 3, -1. Axis of symmetry is always going to be the line that goes through the vertex. It will always have the same x value as the vertex, so x equals 3 is that axis of symmetry. This one opened down because it was a negative out in front. The a value here is negative. X-intercepts on this one does not cross the x-axis, so we would say there are none. The y-intercept is where x equals 0. So if you think about where x equals 0, you can't see it here on the graph. It would go down here eventually, but if you plug in 0 here and here for x, you're just left with -10. So that y-intercept is always the same as your c value in the standard form equation. So this would be y-intercept y equals -10. The range is y is less than or equal to -1. So -1 is as high as it gets. Anything else is a possibility on the parabola, all the way down to -infinity, but it can't get any higher than -1. Number 30, find standard form from vertex form. We're doing this. We're doing 2 times this thing squared is the same thing as saying that times itself. And then the +2 is hanging out there at the end. So from there, multiply everything by x and then multiply everything by -5. You've got x squared minus 5x, and then you have on the inside here minus 5x, and then the last part there would be plus 25. After that, you still have the +2. Combined like terms, you have -10x plus 25 plus 2. That means you have 2x squared minus 20x plus 50 plus 2. I just distributed the 2 to everything, but I don't distribute it to that because that's not in parentheses. From there, last step is to combine the last 2 terms here at the end. Just combine like terms, it looks like that. So that is standard form, your final answer. Your A is 2, B is -20, C is 52. From there, G of x. This one, you'd have x minus 8 times itself, minus 4. Multiplying that together, you have x squared, and then x times -8. You have that twice, so -8x twice, and then -8 times -8 is a positive 64. Minus 4 is still hanging out there. 1/2 times x squared minus combined like terms, that's minus 16x plus 64. Minus 4, this is going to be 1/2. If I distribute that through to each piece, 1/2 x squared minus 8x, half of 16 is 8, minus half of 64, that'd be 32. And that minus 4, final answer would be 1/2 x squared minus 8x plus 28. From there, solutions by completing the square. So a couple more of these. This is going to be x squared plus 6x divided by 2 squared. That's 9. So a minus 9 after that. This would be x plus 3 squared minus 81 equals 0. If you add 81 to both sides and then take the square root of both sides, not forgetting to put your plus or minus right there. Square and square cancel. X plus 3 is plus or minus 9. Subtract 3 from both sides. You've got x equals -3 plus or minus 9. So your two options are to add or subtract. If you add 9, you're going to have 6. If you subtract 9, you're going to have -12. So 6 or -12 here. For 34, same idea. Group those two together, complete the square with those two. So you're going to have that divided by 2 squared is 16. A minus 16 goes out there, minus 9 is still there. This would be x plus 4 squared minus 25 equals 0. If I add 25 to both sides, we've got x plus 4 squared equals 25. We're going to take the square root of both sides, not forgetting the plus or minus. This would be x plus 4 equals plus or minus 5 there, subtracting 4 from both sides. Leaves you with x equals -4 plus or minus 5. That's x equals, this is 1 or -9. 35. So we're by observation answering A and B. Does it have a maximum or minimum? Well, because of this A value being negative, that means it would open down, meaning it would have a maximum, a high point right there. So a maximum, because it opens down, and it opens down because A is negative. So you could say that as well. So it opens down, A is negative is another way to think about that. And the parabola will be wide, narrow, or normal. Well, if it was normal, it would be 1 or -1 out in front. If it's wide, that's going to be between -1 and 1. And if it's narrow, it's going to grow faster. This is going to be either less than -1 or greater than +1. So a quick way to say that is the absolute value of A is greater than 1. That is why it's going to be narrow. It's going to grow faster. For the vertex, the x value is always -b over 2a. So if we look here, your a is -2, your b is -12, your c -16. This would be negative, or the opposite of -12 over 2 times a, 2 times -2. That's 12 over -4, which is -3 right there. And I promise that is a 4 and not a 9. It kind of looked like a 9 there. So there we go. And then from there, create a table. So we almost have our vertex, not quite yet, but I know that the vertex x value is -3. I'm going to try to find the y value that goes along with that. So x and f of x. Let's put the vertex in the middle. So we know this point, and this point is going to come from that. So you're going to have -2 times -3 squared minus 12 times -3 minus 16. Show the work for that. And we'd have -2 times 9 right there. This would be +36 minus 16. That'd be -18 plus 36 minus 16. Putting all those together gives you 2. So your f of x for the vertex, your y value in other words, is 2. The vertex would be 3, 2. If we graph that, -3, the vertex would be -3, 2. So if we graph that, -3, 2 is right here. We know it opens down because of that negative a value, and we know it grows twice as fast because of that 2. So normally 1 and 1, now it's 1 and 2. Normally 2 and 4, now it's 2 and 8. Other side looks exactly the same. Connecting those with a good parabola looks something like that. And then from there we could find these other values by plugging in these x values. So I would go, if I'm going up from or to the right of -3, I'd have -2, -1 going this way, and I'd have -4, -5 going back to the left the other way. You could plug in either of these two into the equation and figure out your f of x values from there. Symmetry on the other side, or if you graph it, you can look at the graph and come up with the values from there. So 0 and 0. And -6, -6 here and here. Looking at the graph, those are the coordinate points. The equation for the axis of symmetry is always x equals, and then that line right there, wherever it goes to the vertex. So it's always x equals, and then the x value of the vertex. The zeros, right here and right here, that's where you have x-intercepts. Those are solutions. So we have the zeros, x equals -4 would be one solution, -2 would be the other solution. The y-intercept is where x equals 0. We can't see it here on the graph, but if we plugged in 0 here and here, these a and b parts would cancel. You'd be left with -16. So y equals -16 would be the y-intercept, and then the range is going to be from 2 on down. So y is less than or equal to 2. 36, standard form from vertex form. So we're doing this, expanding it out again. X plus 3 times x plus 3, and then with 4 after that. So the negative sign's still hanging out there. This is x squared, and then x times 3x, 3x, 3 times x, another 3x. 3 times 3 is 9. Combine like terms. You have x squared plus 6x plus 9 plus 4 on the outside of the parentheses. Distribute that negative to the parenthesis part. It looks like this. And then combine -9 and 4 together. You have -6x minus 5 right there. So negative x squared minus 6x minus 5. That's your standard form. From here, this one, same idea. You're going to expand that out. X minus 12 times itself plus 6. This is negative 2 times x squared minus 12x written twice plus 144. If you multiply each term here by each term here, and you still have a plus 6 after that. So that would be x squared minus 24x plus 144. And then plus 6 outside. Distribute that negative 2 through to everything. Negative 2x then squared plus 48x minus 288 plus 6. Combine like terms, and you're left with negative 282 at the end there. So negative 2x squared plus 48x minus 282 is what we end up with. Looking to number 38 now, almost there, getting close. What are the dimensions of the largest piece of cardboard possible? So if you have something that looks like this, and you see dimensions of the largest piece possible, you're thinking maximum area possible. Your area would be length times width. Since it's just a rectangle, this could be considered our length, this could be considered our width. So we have 2x minus 4 times negative x plus 10. We're trying to maximize this equation. We're trying to find the vertex value, in other words, of this equation. So if I multiply that out, that's negative 2x squared for that times that. And then 2x times 10 is 20x. Negative 4 times x is plus 4x, positive 4x. Negative 4 times 10, negative 40. Combining like terms, it looks like I would have this. So right here I have my A, my B, and my C. And if I'm going to find the area of the largest piece possible, I'm finding the vertex. I know this one opens down because of this value being, the A value being negative. So I'm looking for that high point. The high point represents, well, the parabola represents the area. That's what this whole formula is, the area given a certain x value. And then the high point represents the highest or largest area. So from there, let's find the vertex. That will find that point. That will be the maximizing value of this formula. So the vertex x value is going to be x equals negative b over 2a. That's negative 24 over 2 times negative 2. That's negative 24 over negative 4, which is 6. So from there, your f of x value, or your a of x in this case, a of 6, would equal, we plug it in, negative 2 times 6 squared plus 24 times 6 minus 40. That would be, it looks like this is 36, so that times negative 2 would be negative 72. That would be 144 right there, minus 40. And this would be negative 112, that part together, leaving you with 32 for the maximum area. So the best area is going to be 32. And the dimensions, I would just plug in 6 into here and into here. So the dimensions, to answer the question they asked, I need to tell you need to tell me what the dimensions are. So we have the length, the L is 2x minus 4, which is 2 times, we decided 6 was the maximum or the best value for x. That would be 12 minus 4, which equals 8. So 8 units for the best length. And then the best width is going to be negative x plus 10. So that's negative 6 plus 10. That's negative 6 plus 10 is 4. So 4 units for the width. And then the area would be length times width, L times W, which is going to be 8 times 4, which is 32 units squared, which is what we expected based on the fact that that was the y value of the vertex. And the y value of the vertex being the area right there, since it's the area given a certain x value. From there, 39, if a rocket is launched vertically upward from the ground level from ground level, 0, height is 0 in other words, with an initial velocity of 120 of 128 feet per second, and its height h in feet after t seconds could be modeled by this function. So this is an important function here. In this one we have an a value of -16, a b value of 128, and there is no c, so the c value would be 0. If we're looking for how long it took to return to the ground, here we're saying the height would have to be 0 for that to happen. So we're looking for, when is this true? When does 0, I'm replacing h with 0 here. The h of t part becomes a 0. When is this true? So plus 128t. You can do your GCF here. You can factor out a -16t out of both of those. If you divide each term by -16t, that's what you have left in the parentheses inside here. So this would be t, and this would be excuse me, -8. So right here, the factor, the number that would make this factor 0 would be 0, and then this one would be 8. So these are solutions to that, but this, we don't want to use that one. This is when it leaves the ground. So that's when it takes off, in other words. We want to use this one. So 8, and this would be in terms of how long, include units. We want to say 8 seconds right there. How long will it take for the rocket to reach its maximum height? So when you see that, you should be thinking, aha, vertex, maximum. And what is the maximum height? So what is the maximum height? If we're going to use the vertex idea, we're saying that the vertex, the x value is -b over 2a. We know a and b are right here. We have -128 over 2 times -16. That's -128 over -32. So that is 4 seconds for the time at which that happens. And then the maximum height itself is going to be the f value, the f of x value, or the h of t value in this case, given 4 seconds. So -16 times 4 squared plus 128 times 4. That would be, this would be 16. 4 squared is 16. 16 times 16 is 256, so that's got to be -256. This is 512 right there. So that would be 256 feet for the maximum height. And then how many seconds will it take for the rocket to reach 112 feet above the ground? This means your h value is 112. We're trying to solve for how many seconds? We're trying to solve for t. So we're saying that 112 now instead would equal -16t squared plus 128t. If you subtract 112 from both sides, we're going to do that whenever we try to use factoring to get one side equal to 0. That's what we're trying to do here. So this looks like that, and then from there you can take out the GCF would be -16t. T squared minus, if I divide everything here by -16, not -16t in this case because you can't take a t out of that part. So this would be minus 8t, this would be plus 7. So you've got 0 equals -16, and this would be, if you factor this out, 7, -8. You can write out the factors of 7. That would just be 1 and 7. They'd both have to be negative to get a negative sum, or a -8. So t minus 1, t minus 7. This one would have to be 1. This one would have to be 7. You could say 1 or 7 seconds. That's when that happens. And if we're going to label the points on the parabola, if this is at 112 feet, this one would be 0, 0. This is where it starts, where it leaves the ground right here. This one would be where it returns to the ground. So it went up, hits its maximum point, back down. We saw it return to the ground at 8 seconds right there. So 8 and 0 would be that value. If this is at 112, and we just calculated that here, we're saying 1 second or 7 seconds. So this would have to be 1 and 112. And this one would have to be 7 and 112. And then the maximum height right here, that's the vertex. That's 4, 256. So 4 and then 256 is the highest point that it reaches. The Pepsi problem here, if the Pepsi Cola company charges $1 for a bottle of soda, 24 out of every 100 people that buy a soda will buy a Pepsi. However, when they increase the price by 10 cents, one customer stops buying Pepsi. The revenue brought into Pepsi is a product of the number of people buying Pepsi and the price of each bottle of Pepsi. So it's the number of people that buy a Pepsi times however many bottles get bought, or times however much the price is, I mean to say, for that. So write an expression for the price of a bottle of Pepsi. Well, it starts at $1, and I'm going to call that 100 cents. And then every time we're increasing the price by 10 cents. So X really is my number of 10-cent increases. So here I'm saying 100, what it starts at, plus however many times I increase it, times 10. That's going to be the expression for the price of a bottle of Pepsi. For the other part here, an expression for the number of purchases of soda, you've got 24 people buying it initially, but if you raise the price one time, you lose a customer. So one customer stops buying a Pepsi. That means you'd have minus a 1x or minus an x. So if you raise the price twice by 20 cents, two 10-cent increases, you'd lose 2 customers. You'd only have 22 people buying. From there, the best price is going to be this times this maximized. So we're looking for when can we get the maximum value here? 100 plus 10x times 24 minus x. So we're trying to find the vertex of that. If we multiply this out, we would have 100 times 24, that's 2400. 100 times negative x, that's negative 100x. 10x times 240, or times 24 is 240, so 240x, and then 10x times negative x, negative 10x squared. If we write that in standard form, that will help us figure out our a, b, and c, which helps us determine our vertex. It looks like that after we combine like terms. So this is really an important piece of information there. From there, we know our a is negative 10. We know our b is 140. We know our c is 2400. So we have the vertex for the x value is negative b, negative 140, over 2 times a, negative 10. This is negative 140 over negative 20, which would be 7. So it looks like 7 is the best number of increases. So that would imply that the best price is going to be what we started with, $1 plus 7 10-cent increases, plus 7 times 10 in other words. So this would be 100 plus 70. The best price then would be 170 cents, or probably better stated would be $1.70. So that's your best price. And then the maximum that R of x can be is going to be this plugged into R of x. That's going to be your maximum value of the vertex. So if you were to graph this, because that value is negative out in front, the general shape is like this, and we're looking for that high point. So we know it's over 7, and then we're trying to figure out what is that y value right there. So in other words, in this case, what's that R of x value, since we're using R of x instead of y or f of x. So we're saying R of 7, plug in 7 into here, that's negative 10 times 7 squared, plus 140 times 7 plus 2400. Looks like that would be, this would be 49 times negative 10, that's negative 490. This would be 7 times 140, that'd be 980 plus 2400. And then if we add all this together, this would be 490, that part, and so adding that to 2400 would be 2890. That many cents would be the maximum revenue. In terms of dollars, $28.90. So really, if we increase the price 10 cents 7 times, we're gaining 70 cents per bottle, but we're losing 24 minus 7 customers. But because of this, if we charged $1, the zero value would actually be right here. This would be 0 and 2400, or $24. But then we actually make more money overall if we charge a little more. Even though fewer people are buying, the total revenue is more. And then 41, 42, finishing up with this, determine a linear equation given these points, and then find f of 20. So we can make an xy table. We're saying 2 and 6. We can say 3 and negative 18. Your change in x is just 1, so really it's just what's your change in y. So you can find for your m value, in y minus y1 equals m times x minus x1 in point slope form right there. Your m is just y2 minus y1, negative 18 minus 6. So your m value, it's going down. We're subtracting 24 as we go from there to there. So we take this. I'm going to use this as my point for my x1, y1 right there. So that's y minus 6 equals negative 24 times x minus 2. And we're going to get the equation. So I want to get y by itself here. This is going to be y minus 6. Distribute the negative 24. It looks like that. If I add 6 to both sides, I've got y, which I could say is f of x, is going to equal negative 24x plus 54. So that's my equation. And then if I want to determine f of 20 from there, I'm going to plug in 20. So negative 24 times 20 plus 54. This would be negative, it looks like 480 plus 54. And that would be negative 426. So f of 20, negative 426. That makes sense if you think about it, because if you look at that table and you keep subtracting 24 until you get to an x value of 20 over here, you keep subtracting 24 every time, you're going to get a pretty big negative number, a pretty negative number from there. Exponential equation, remember you can use y equals, and then you can use y1 in front. You can use r for the ratio. X minus x1 goes there. So on this one, you've got an xy table that would look like this. Looks like you're getting smaller, so as we go from here to here, we're multiplying by something that's less than 1. To get this, since this is just a change in 1, we can just say the ratio is the second term divided by the first. So it's this divided by 12. You could say that's negative 0.25, or you could say that's negative 1/4. Either one of those would work. And so if I use this right here, I would have y equals 12, y1, and then I'm using this as my ratio. So I'm going to say negative 0.25 there instead of negative 1/4. You could say that as well though. And then x minus x1, x minus 5. So you could also write right here, you could plug in negative 3 for y1, and then you could plug in a 6 here. That would also work. Up here you could have done something similar. You could have plugged in 3 here instead of 2, but you'd have to plug in negative 18 there for y1. So it would actually be y minus negative 18 up there instead. But both would give you the same equation, or give you the same values in the end. So this would be a valid equation, exponential equation. And then if we plug in for f of negative 2, if we plug in negative 2, this is like f of x equals y, which equals that. So you'd have 12 times negative 0.25 and negative 2 minus 5. That would be the same thing as 12 times negative 0.25 to the negative 7 power. Putting that into a calculator actually gives you a pretty big number, because it's like the reciprocal of this. It's like saying negative 4 over 1 to the positive 7 power. So 12 times 4 to the negative 4 to the positive 7 ends up giving you this, negative 196,608. So, woo, that was a lot there. But if you can do all those problems, you're going to do great on the test. If you understand everything we did there, you are good to go. Go back and review as you need to. Let me know if you have any questions or comments. Feel free to comment down the video if you noticed any mistakes. If you liked the video, if you appreciated it, I always appreciate those likes and comments. Go back and review as needed. Hope you have a great day. Hope you are studying hard for the test if you're one of my students. And hope you do really, really well. Have a good one. I'll see you guys later.